Okay, this is physics 5.03 part 2. So we're going to work on that second picture. What if we have multiple angles? We've got a 12-kilogram picture suspended from a ceiling on a wire that makes an angle of 25 degrees with the vertical on either side. What is the tension in one of the wires? So we've got basically, if I'm just drawing an actual diagram, what are we hanging? A picture or a ceiling kind of seems like an odd way to hang a picture. But our axis is going to come down here, and these angles are both going to be 25 degrees. So that's what we've got going on. We're going to go with a standard coordinate system here. And let's draw the free body diagram. Okay, so before we start drawing in vectors, what are my forces here? All right, you could tell I was starting to draw the weight vector, so we're going to have F sub W. And then you might have said, well, we've got tension. Well, you actually have tension. So you've got tension here and you've got tension here. So we're going to call that FT1 and FT2. And they're going to be equal. So let's start off. I always start with the weight vector because the weight vector never changes. And we know that this is 12. And again, I'm going to take acceleration. I'm going to round that to 10. No, I better not because I did all my math ahead of time and I used 9.81. So never mind, scratch that. So that means this is going to have a force of negative 117.72. Okay, I'm going to bring a vertical up so I can draw my 25 degree. So there's my vertical axis. And I've got FT1. So I need about a 25 degree angle here on either side. FT1 and FT2. They should have the same length and they should have the same degree. So I don't know that I'm exactly on point, but I'm pretty close. So you might be thinking, well, if my weight's that, can't I take that and divide it by 2? And the answer is no. See if you can figure out why. So when I resolve these out, this you can only look at vectors that are on the same plane. So I can only analyze vectors that are parallel or anti-parallel. Is this parallel to this? It's not. In order to analyze this, we're going to have to draw in components. These vectors and this vector can be analyzed together, but these two are in a different plane. So I'm going to redraw this. I'm going to kind of expand this. So let's just do let's do FT1. So I'm going to give myself let's see if that's my horizontal. 25. Whoops, already had FT1 there. Okay. So when I draw in my components, I have FT1Y and I have FT1X. This guy's got to be negative because it's in the negative direction, and this one's going to be positive. That's a 25 degree angle. My trig function is going to be cosine. Again, I'm resolving against the vertical. So I don't know what my hypotenuse is, so I'm just going to leave it as FT1 cosine 25. And this guy, so we're just going to leave this as an FT1x. When I draw in FT2 I'm going to have the same thing. So I'm going to have FT2 cosine 25. So this is FT2y is going to be equal to, and FT2x is going to be equal to positive. It's going to have a value of positive. Well, I know the tension is going to be the same. I just don't know what it is. So I can just change this basically to FT. So where's my motion analysis? Well, we're hanging there. We have no motion. So that means that my F nets have to be equal to 0. That means that in my horizontal, so my F net X has to be equal to 0, and my F net Y has to be equal to 0, because I have no motion. Well, you can see, yeah, these are going to be equal and opposite. These are my only two horizontal. So that means that this weight vector has to be equal and opposite to these two FTY vectors. So to solve for tension, I can bring this and this plus that, and know it has to equal 0. And when I do this, I'm going to just rewrite it as FT, because I know they're the same. So this gives me, by the way, what's cosine of 25? It is 0.906. So cosine 25 is 0.906. It's going to give me 0.906 FT, that's this one, plus 0.906 FT. This would actually be the FT1, FT2, but you know they're the same, minus 117.72 has to equal 0. And when I solve, I get a tension of 65 newtons. So again, we had motion. So what's our takeaway here? And hopefully I drew this correctly, where these two vectors are going to be the same length as this vector. So my vector should be to scale. So when we're talking about, again, in this case, a problem that has multiple angled vectors, it's important to note that my motion has to match, and this little green X meant no motion. My motion determines what I can and can't do, both in my calculations and my free body diagram. Because I have no motion, my horizontal components have to equal 0, my vertical components have to equal 0. So because I have the angles, that gave me my trig functions, and I was able to actually solve because I was able to set this equal to 0. So again, there's that motion analysis. You have to be able to do it. Also remember, the common toe tripper here is that you can't just take these and divide by 2. These are not parallel, anti-parallel. Vectors have to be broken down into their components. All right, that was part 2 of 5.03. Thanks for watching. Have a good day.